Hi, my name is Roland. I'm working for the Danish company DaniSense, and I want to give you a short introduction how to measure the residual current with our new residual current monitor SRCM H070B+. And as you can see here in the picture, you can make a connection to our Windows-based software solution, and it's very easy. And I want to show you how you can start with this device. Here, for further information, you can write me an email. Here is my email address. Yeah, let's go. So yeah, if you open our package of the SRCM residual current monitor, you can find a Phoenix Contact connector, which fits into our port here. And of course, you can find a USB cable with 2 meter length with a USB A to micro USB B plug. And the micro USB B plug, you can put it in the USB port here on the black-sided side of the device. Yeah, and of course we are measuring the residual current, and that's why we have to put all the active cables through the hole of this sensor, which is about 70 millimeters. And yeah, we have to put all these cables together. Maybe a cable tie can help because all the electromagnetic fields of these conductors have to cancel each out. And cable ties can be very helpful. And here on the red side, red painted side, you can find also some small holes where you can fix the cables for proper installation. Yeah, now I have connected a 24-volt DC power supply in this position of the connector. You can find the diagram in the data sheet, and I've used now position 1 and position 3 with our 24-volt DC power supply. And of course you can here on the position 7 and 9 you can receive the 4 to 20 milliamp output signal. And yeah, how to start, and when you have powered the device, you can press these two buttons here, and afterwards an algorithm is started. If you have pressed a minimum of 3 seconds these buttons, a processing takes place approximately 10 seconds, and in this time an algorithm is analyzing the waveform and the signal, and this algorithm makes a proposal, and this proposal is flashing for maximum 10 seconds, and you can accept this proposal with pressing the test button. And then we are ready to go. Yeah, for the software, we have to go on our website, danisense.com. And here under products, you can find residual current monitoring. Press this one. And here we can find some information. And here we can find the Smart RCM software link. I press this link and our software is downloaded immediately. Yeah, now I have downloaded the software and installed it on my Windows computer. And yeah, now we can see on the left hand side that under Start we can find our SRCM device. And here are, of course, the proper settings we have activated by the algorithm by pressing the two buttons. And now we can see here the serial number and the name. Yeah, here I can choose another one, but now I choose the SRCM machine 1. And of course, yeah, measurements, the relay trips, no. The true RMS for relay, this one is a little bit smaller than the residual current true RMS. We measure here up to 20 kilohertz, and the higher harmonics for the relay are damped a little bit because of the special international standards for these devices. And we can see here the device info, supply voltage okay, temperature okay, firmware version okay. So yeah, we have here the proper settings by the algorithm, and we can choose by hand as well. But if we change now under 500 milliamps, for example 300 milliamps, we can see here that the range we can measure with the 4 to 20 milliamp output is from 0 to 400 milliamps. And if I go back to the 500, it changes to 0 to 2000 milliamps. So now I have a bigger range which is transferred to the 4 to 20 milliamp output. Yeah, and of course I can change here the frequency up to 100 kilohertz as specified in our datasheet. And yeah, let's perform the test of the relay. It's like pressing the test button at your RCD at home. So it takes a little bit time. Yeah, okay, everything is fine now. Yeah, now we can go to the fast Fourier transform. Yeah, and we can perform the fast Fourier transform on these options. Analog full bandwidth, which means we measure up to 100 kilohertz. And the selected frequency range, we have at the moment 20 kilohertz. And the relay filtered range. So we can start now with a 100 kilohertz bandwidth, and for the time interval I choose the 2 seconds, and now I start the fast Fourier transform. Yeah, I have to say that at the moment I'm not measuring residual current, only the current which flows into my computer equipment. So we can see here a high amplitude at 50 Hertz. And of course, my computer equipment is power supplied by, yeah, these are nonlinear Lords, and the third harmonic is very high. So we can see here 150 Hertz, a higher amplitude as well. And yeah, we can see here that the higher harmonics are located mainly between 100 Hertz and 2 kilohertz, because above these 2 kilohertz there are no high amplitudes, which are taken into account by the true RMS value. Okay. Yeah, now we can have a look at the selected frequency range. So there should be no big changes because we don't have any higher amplitudes in this higher range. Yes, the waveform looks nearly the same, and this is very interesting if we choose the relay filtered waveform. You can see here that the higher harmonics are damped a little bit, and that's because of the standards, because they are taking into account that for some frequency converters you have some noise or higher frequencies due to the filters which are in the devices. So, and very interesting, if we go backwards, we can choose 100 Hertz again. And now we can change to the selected frequency, so we perform the waveform only up to 100 Hertz. And here you can see a strong damping, and you can see here a nearly sinusoidal waveform. Yeah, that's it with the FFT analysis. Now we come to the data logging, and we have here different logging intervals. I will choose the 1 second, and of course now we can start logging of the true RMS value, and the data is written on my hard disk. So it depends on your hard disk space how long you can perform this logging. Yeah, and you can see here that the relay is not triggered, and the values are around 240, 250 milliamps. And now I can switch on my LED lamp. Yeah, and you can see that the true RMS is going a little bit higher. Yeah, we can stop logging now, and we can save the data to a CSV file. Okay, this is a new one, and we save it. Yeah, now we can see in the downloads the new file we have generated, and yeah, we can start Excel now. And here it is, the file. We have a timestamp and a column where the relay is monitored every time false, of course. And we have here the true RMS values. That's it. I hope you enjoyed this small introduction, and see you soon.